importantly, accessibility to energy. Energy generation accessibility is crucial to the continued development that the continent faces, and it directly affects the lives and livelihoods of those living in urban and rural settlements and environments. And I think what has happened is much of this energy deficit is because of a great reliance on fossil fuels. See, but ultimately, there is a diversion towards more renewable energy sources. But why is it that there are obstacles and challenges, and how might these challenges be mitigated? In order to tackle the bioenergy challenges, different African governments have put together different policies to kind of enhance interest and take-ups of renewable energy systems and products and services. One of those is around bioenergy. Now, bioenergy systems of waste to energy is well developed in several economies internationally. But how come with the deficit in energy in Africa, the uptake has still been very, very low? What seems to be the problem? Is it because there is low cost? Is it because there is not knowledge of the systems in place? Is it because of government policies? What really is the problem? So today, we're hoping to showcase an actual project managed and be funded by the Global Challenges Research Fund under Lancaster University and as a range of African partners to set up an actual waste-to-energy plant, like a demonstrator/show lab in Nigeria at the University of Benin and in Ghana. And you'd hear our colleagues speak about this today. And I think, in a sense, it's to kind of assess the issues, the challenges in setting these plans up. What has been the engagement processes with the communities, and how might there be how might these systems or plans be upgraded, replicated in other economies or institutions? That is basically the theme or the subject matter of our discussion today. And so without much further ado, I want to invite a gentleman who is the lead and principal investigator on the ACTUATE project, the RECIRCULATE project, Professor Keksempo, who will give us an overview of what the project is about and fundamentally the objectives of today's webinar. And at some point at the end of the webinar, he would come back to give us a wrap-up. And so with absolute pleasure, I wish to invite Professor Keksempo to give us an introduction to today's session.
Thank you very much, Akan. It's a real pleasure to be here, and thanks for your very kind introduction. Akan, can you see the presentation?
Very clearly, sir.
Excellent. Well, good morning, everyone, and welcome to this webinar, which focuses on bioenergy and particularly the ACTUATE project. It's a pleasure to have you all join us today. So thank you very much for taking the time to attend. So yes, the ACTUATE project is a project that's funded by the British government under the Global Challenges Research Fund. And the formal title of the project is Accelerating the Adoption of Circular Sanitation Demonstration Systems for Improved Health Outcomes. It's a lot easier to say ACTUATE. And this is funded under the Global Research Translation Award, and the project started in October 2019 and will terminate or finish at the end of this year. So as Akan has said, my name is Professor Keksempo. I'm an academic at Lancaster University. I have the pleasure of being the lead scientist for both the RECIRCULATE and ACTUATE projects, and I'm also heavily involved in international activities within the university. So before I talk about the project specifically, maybe a little bit of background would be in order. So the project, and at large, is couched within the notion of the circular economy. Some call it the green economy. But anyway, it's about where, instead of throwing away waste or producing waste, we try to reduce the amount of waste that we produce. And indeed, we actually look to reuse and recycle that waste, so give it value for the benefit of us as a population, as a society, but also in terms of the environment as well. And of course, the circular economy is being looked at and has been adopted to a greater or lesser extent in many countries around the world. But for the purposes of this project and of course the Recirculate project, which I'll mention in a moment, we're focusing on how we can work with our African partners and colleagues to grow transformational impact through working with and for their communities. And through eco-innovation, we look to develop new products, processes and interventions and services, that benefit both society and the environment. So focusing in on the circular economy that's relevant to what we're doing collaboratively in Africa is the notion of the waste, energy, food nexus, and how that relates to the circular or green economy. And so in sort of essence, we're looking to take wastes, organic wastes, which we would normally throw away, and of course that can lead to human health and environmental health problems. Instead of throwing it away, we actually see it as valuable as a resource, and through sustainable energy solutions, particularly bioenergy, and for the purposes of this project, we're focusing on anaerobic digestion. We use those waste products to produce energy rich products such as biogas, which we can then use to convert to electricity, heat, light, cooling, and so on. And as with any process such as this, it produces its own waste. And in this case, it's anaerobic digestate, which again we could throw away. But in essence, we would like to take that anaerobic digestate and use it as a source of irrigation for plant growth in agriculture, or indeed more important, or equally importantly, as a sustainable fertilizer alternative to conventional inorganic nitrogen and phosphorus-based fertilizers. Now, at the heart of our collaborations with partners in Africa is this notion of not only working with the universities and the research institutes, but also to work with the private sector, to work with government and particularly policy, and of course, more importantly, as these projects have developed, to work with our communities and civil society. And our ambition is that these partnerships that we're engaging in are actually equitable. There is a genuine sense of collaboration and equity across the projects. So that really takes us to the Recirculate project, or give it its full title, Driving Eco-Innovation in Africa, Capacity Building for a Safe Circular Water Economy, where, again, through funding from the Global Challenges Research Fund to the tune of £7 million, we were able to form a strong and dynamic collaboration with partners in Ghana, Nigeria, Kenya, Malawi, Zambia and Botswana. And this project, which I'll talk a little bit more in a minute, was also directed at a number of the UN Sustainable Development Goals as well. And you can see some of those along the bottom of the slide. So what does it look like? Well, basically, as I said before, we're taking waste. It might be domestic waste, it might be human waste, it might be agricultural waste, and bringing it all together to react it in an anaerobic digester. So in the first instance, we're taking waste and protecting health through sanitation mechanisms to use that waste to produce energy in the form of biogas. As I mentioned before, the digestate is then used potentially as a fertilizer or soil conditioner or a source of irrigation to support sustainable food production. But as with bioenergy, agriculture also produces waste, and this can then feed back into, this can then feed back into the collection of that waste, and therefore the cycle is complete. So it is genuinely a virtuous circular economy. Now, there's been a lot of work done under the Recirculate project in the lab and with communities and so on. Heavy emphasis on science and technology, but also on knowledge exchange and partnership building, and of course in the entrepreneurial and innovative sectors. And really what ACTUATE does is it brings that sort of science and technology and all of that community-based understanding to a much more practical level. So what we are hoping to do with what we are doing with our partners in Ghana and Nigeria is actually building 2 demonstrators. Now, that way we actually generate something that people can see. They can touch it. They can. I don't recommend tasting it, but they can certainly see it. With a number of different partners across different disciplines, we're progressing very well through this project. So what are the aims of ACTUATE? Well, of course, as I've already covered, to look at the circular economy in this waste, energy, food nexus, to build these demonstrators and associated show labs, to offer educational and capacity building tools to help understand the circular economy and gain its acceptance, actually valorizing waste, enhancing the value of waste and the production of energy. And finally, we want to bring our partners together through these demonstrators in Accra, in Ghana, and Uniben, the campus Uniben in Nigeria, to work together effectively and help to promote and develop this entity. So really, through this translation project and this notion of the circular economy, working with our partners, we look to offer solutions for waste management, improved health and sustainable energy and food security, education in terms of acceptance of the circular economy, generational and cultural change, embracing that circular economy within the communities that we're working with, and finally, to develop new entrepreneurial business models which will maximise the economic benefits of the circular economy. And of course, to achieve this, working with the communities, with the people who live in the communities, with research institutes, universities, NGOs, to look at how we can improve human health and environment, and to develop safer and sustainable practices within these communities. And of course, thinking about the longevity and the sustainability of these projects is to engage with SMEs and entrepreneurs to support the expansion of this in a commercial way, and also to develop training opportunities within stakeholders to ensure that continuity and sustainability. So today, there are a number of objectives, and I think Akan has already covered those, but I've presented those on the slide. But I'd like to just acknowledge and thank, of course, the presenters that will engage with you in this webinar. So a good friend and colleague, Professor Lawrence Ezemonye, Patience, Nina, and Richard, of course, as well, all highly important in this project. So I hope that you enjoy this and take something away from this. And of course, maybe this is an opportunity to continue the discussion with us and our partners on the ground. So I'd just like to thank everyone for listening, and I hope you really enjoy the webinar. Back to you, Akan. Thank you.
Thank you very much, sir. That's absolutely well captured as an overview into the project. We're going to have a series of discussions today, and I'm hoping that there will also be an opportunity for some interactions from the audience. But I think it's important for us to have a background, like setting the scene of why this project has come about. What is the fundamental challenge in different African countries? Why is it important to have a plant of this nature? Now, Keck has spoken about this in some sense, but maybe I would like to invite an interesting personality to come and talk about or set the scene so everyone can understand the framing with respect to the issues around waste and sanitation, and ultimately the importance of having a demonstrator plant in different African countries. And I want to invite Professor Richard Ruza Peacock, who is a professor of environmental and human health with an expertise in molecular microbial ecology and environmental microbiology. Roger will give us a scene, or a scenario of the basis or the premise for this very project. Over to you, Roger. Thank you, sir.
Yeah, thanks, Hakan. I'll just share my screen and go through this torturous process of trying to set up a PowerPoint presentation. And should start. We've always got a background. Can you see that okay?
Yes, very clearly, yes.
Excellent. Right, okay. So yeah, I'm Roger Pick. I'm Professor of Biomedicine at Lancaster and a microbiologist, as Hakan said, and I'm also part of the Recirculate and Actuate programs. And I just want to give a little bit of background of how this project evolved. And it's not just one person; it's lots of people. And one of the key things, it's lots of disciplines. It's not just a microbiologist or a social scientist. We can't do it by ourselves. We have to do it as a group, as a big multidisciplinary project. A couple of slides which duplicate Kirk's, but they just kind of reinforce what he said. This is the Actuate program, and one of the key things here is it is a collaboration between ourselves in the UK. It's our partners in Nigeria and our partners in Ghana as well, and we are funded by one of the UKRI, British Research Councils, and this is what Recirculate. Without Recirculate, we probably wouldn't have got to this point at all. And Recirculate is a very complex, it's a big project, it's multidisciplinary, but it can be just kind of summarized to a certain extent that in the middle of it, no matter what we're trying, we have 4 or 5 work packages, all doing slightly different things. But in there are some very common themes, and one of it is waste. Water is another common theme. So we have here, looking at this kind of circular economy, as Kirk said, we're taking waste, we're trying to make it into a resource, and we're trying to give it value. And within the project, we have a number of work packages. So work package 4 looks at waste and anaerobic digestion. Work package 2, which I'm involved in, looks at sanitation. Our waste, we're trying to get rid of from the community because to improve health, you've got to do something with that waste. And hopefully work package 4 can do that. And then work package 3 uses this waste as a resource for increasing food production. In all this, we build new links, and we're across a lot of partners. So what we've got there is a fantastic circular project where waste is one of the key themes. And common things within Recirculate and Actuate, as we start to make this transition and we develop this new project, was obviously what I said was waste. It was really trying to give waste a value, rather than just being waste and discarded and it becomes a problem. It has a commercial value, but it also has an educational value in training, building partnerships, and also with the youth and schools, telling them that waste has a value. And what are the outcomes of that? Probably health improvements. That's one thing we work in work package 2 of Recirculate. This commercial value, developing entrepreneurship, crop improvement, food production, producing of biogas and energy, and also environmental improvement. If we can do something with the waste, we improve the environment. So in Recirculate, we're not actually at Actuate at the moment. We have this in work package 2. We have this problem here of waste in the community, mainly fecal waste. So what we've been able to do, and it fits in with Recirculate, is use digesters, anaerobic digestion, to treat and modify the waste, and eventually put it out to applied models of trying to improve crops. And here we're linked to Blue Skies in Ghana, and this is SSGL in Ghana. And we've got intangible benefits of this and tangible benefits, which are really important. So it's not just processing the waste, there has to be a benefit for it. One is capacity building that we have down here. You're looking at this fecal waste value chain extension, and what we have also is a healthier environment as we remove it. But the intangible ones are starting to kind of migrate into the Actuate theme. Is we've got the youth involved. Hopefully these adolescent kids are there to learn and be change agents. And in this, we wanted to go into Actuate and develop some focus for this for the youth. So we've started to make this transition from Recirculate to the Actuate program. So this is really Recirculate, sanitation for health. We've got fecal waste, water for energy, water package 4. We've got abattoir waste, goes into a digester. So this is the kind of Nigerian side. This is the Ghanaian side. We can hopefully produce biogas, hopefully produce these fertilizers, hopefully do some food production. So that's Recirculate. So where does Actuate fit in? Replace that. We've still got the digester, but we're now using the digester as a demonstrator. We're in the community, we're in the schools, we're in the universities. So we're starting to show these, use these digesters as demonstrators of the value of the waste. And that is the key to Actuate. And how did it start? It does start. It started with other beginnings, not Actuate. And this is the Recirculate weather station at the school in Medina. And this is the opening ceremony where we started to form this community group and the momentum from the community to get people involved. And during that time, this is work package 2. We got together to look at what we could do with digesters and with the waste. And at the same time in Nigeria, the other work package people were looking at the same sort of project. And we came out with a plan which kind of underpinned Actuate. And within this, it was reactor design, because we want to demonstrate a reactor. We need step 2, which is involvement of pupils in the community. This is the core concept. Here, to bring in the pupils in the community, we wanted to design a show lab. We needed to operate the digester. We needed to learn, and people needed to learn how to do that. And this kind of group spilling over, we were able to have a process of engaging the communities, which we've done extensively through our Ghanaian and Nigerian partners. And then at the end, the fourth step was to kind of spread this learning through all these different social media platforms and different ways of getting the message out. And so that was the kind of underpinning ideas within Actuate in Nigeria and in Ghana. And who are our partners? Kirk's already said that. We've got Ghanaian partners, we've got Nigerian partners, all absolutely integral to the success of the Actuate lab project. And this is where I'll leave it. This is Richard and Lawrence are going to talk about how it's developed in Nigeria and in Ghana. But this is the thing I like. This is the concept we had early on. It was just a handwritten diagram on a board which we developed, and we've got this AutoCAD, this idea of the kind of show lab. And so bringing these two together, bringing the education, bringing in the communities was the key to the whole project. And hopefully with Richard and Lawrence will show you how successful we've been in taking these two diagrams which are hand drawn and done by computer into reality, and the reality is the Actuate program. So I'll stop at that point.
Thank you so much, Roger. You know, I find this your last slide very fascinating, because I can actually remember the exact time, day, and location in Ghana on the first meeting we had about the conceptualization of the project, and you brought out a piece of paper and a pen, and we just had this little drawing on a piece of paper, and to see how it has progressed from a paper to a computer or AutoCAD or CAD type structure to an actual physical plant currently existing at the University of Benin and at there's a school in Ghana. I think for me it's a true testament to the work, the hard work, the collaboration, the partnership drive of the different African partners to make this happen. So don't hear from me, let's hear from the folks who actually made this happen. So it gives me absolute pleasure to invite what I might like to call a tripartite team, like a double trio, okay? So Dr. Mike Ajay is a chemical engineer based at University of Benin, but is also a co-investigator on the Actuate project. Then there is Dr. Andrew Avenam, who is the head of the Department of Chemical Engineering, Department of University of Benin, also a co-investigator on the project. And then there is the lovely Nina Ani, who is the chief executive of Avenam Links, a company in Nigeria that specializes in the design and construction of waste-to-energy plants, but also a fundamental partner on the project. They will give us a sense of the process and currently a showcase of what the actual waste-to-energy plant is in Nigeria as we speak. Over to you, lovely people.
Oh.
You need to unmute yourself, Mike. We can hear you, man.
Okay, can you hear me now?
Much clearly. Yes, we can. Yes, boss.
All right. Perhaps I should share my screen, or are you able to share it from where you are?
Share your screen. Let's go with that.
Okay. Okay. I guess it's clear enough. Is it displayed?
Yes, we can see very clearly. Yes, boss.
All right. Okay. So I just tell a short story.
You can enlarge it, like make it a display.
Is he all right? Okay. Good morning, everyone, and welcome to Nigeria. I'm here just to talk about standing in for the team leader, who is Professor Lawrence Ezemonye. It all started from the Recirculate experience. So what are we trying to do? Taking the experience to impact on stakeholder communities in form of research and development, and then taking the research and development out from the theory to something very practicable, something that folks could see. And then also using the opportunity to bridge the gap between the user community and such that people are able to build some businesses around it in form of SMEs. So again, we also try to see it in a way of taking research across all borders, because this research cuts across both Nigeria and Lancaster. So it is not just a credit to Nigeria, but credit to all the partners. Okay, so again, it's also a way to maintain safe and clean environment through biogas generation. So we're taking the waste and then converting it to biogas and letting it be of benefit to everyone, especially those in University of Benin and other stakeholder communities. In Nigeria, there has been some challenges regarding the power situation, because if only you've been in Nigeria, you would have noticed at some point that they could just cut off power at any time, and the next moment they'll bring it back. This is a challenge. So we are also looking to solve a problem that is inherent to the system. Okay, so again, also finding a way to create alternative to inorganic fertilizer by deploying the digestate from the biogas for agro farming.
Sorry, Mike, just quickly, are you currently scrolling through your slide, because it's not moving where we are? We can see it.
Did it move?
No, it's not moving at all. That's the point.
Okay, if you try to, I don't know if you're able to display it, maybe I could just speak to it.
Okay, yes. So, Alan, could you help us share the slides, and then he could just speak to it?
Yeah, I'm going to share it now.
Thank you very much.
Can you see the slides?
Not yet on my screen. Yes, okay. So I think I've passed through this. So, okay, so this is the concept, trying to use the Recirculate experience to impact on every other sub-teams, like the stakeholder communities. We at this point, University of Benin students, which are the USS, the University Staff Secondary School, and then other partners like Avenam Links, PIN, Partnership Initiative in the Niger Delta, and others. Now, the whole idea is to take this waste from these household in University of Benin and convert this food waste to biogas. But we also reckon that food waste is not the only problems associated with as in causing waste in our system. So we also reckon that using a part of fecal waste from cow, which is a regular meat in Nigeria, from the abattoir, will be a good alternative, such that we're able to leverage on the strength of both food and fecal. So we intend to co-digest this food with cow fecal. So when we do that, we are able to get a reasonable percentage of biogas from the digester. So this is the whole idea. As earlier said, bridging the gap between the user community and also finding a way to create get some business owners to get interested in the project, such that they're able to replicate this in small areas, such that they're able to develop their businesses around it. And again, we see also the whole system as doing R&D across borders, bringing every partners, not just about the knowledge base in Nigeria, but also cashing on the experiences of our partners in Lancaster and in Ghana and within us here in Nigeria. And again, we also see this project as a way of cleaning the environment through biogas generation, as earlier said, and then creating alternative to inorganic fertilizer, which we all know some consequences associated with it. So right now, the Recirculate team are also seriously working on trying to study the digestate to examine the amount of pathogens associated with the digestate and finding a way to reduce this as low as practically possible before it can be safely used for crop production. So as Keck earlier said about the nexus for food, energy, water, and the environment. This is just recirculating about around food, water, and energy for the housing. Okay, so I think we should go to the next slide now. So it all started with a project launch, like Professor Roger said, you know, something that started from a freehand drawing, now with series of meetings accompanying the handwritten drawing. As you could see here, this was the first meeting held by the stakeholders. You could see the Ghana team, the Lancaster team represented. That's Professor Alistair and the pilot, and the team lead, Professor Keck, with Professor Lawrence, you know, gorgeously posed in a picture there. Now, this was the first launch, and every stakeholder participated, and we kept going until we got to a point where a conceptual diagram was agreed on. So let's go to the next slide. Okay, so now, while the discussions were going on, we communicated with the University of Benin, who graciously offered to provide a land space that's what we could see on the layout. It's the space is supposed to be for about 14 meter square space for the plan, but along the way they also told us that we could make use of the entire space that's available to us if we can. So if you see to my left, you see that the actual site, which is 20 meters square, was carved out, but the additional to the road on the front and by the side is an addition to it. So which we've also converted to a green space as part of our project. So which we could see along the way as the project continues. Okay. Please, next slide. Okay, so this is a conceptual diagram. Essentially, food waste will come in from the from the residential buildings, and they'll be collected, treated, and then reduced to sizes such that they're able to combine very well with the fecal matter from the abattoir, and then it gets to the site where we mix it to have a uniform slurry from it, and then after that is done, we now transfer the mixture to where we call the batch system, where we are able to know the exact amount of feed that we require to feed the digester. So as you can see, we have a two system digester to receive from the batching pits. And then essentially, with these digesters are connected such that after use, the digestate could be collected from the slurry pits. And then from there, the biogas produced from the digesters are transferred through some cleaning methods. You know, we use the compressor to also collect the gas, but the gas has to pass through some cleaning methods before it's actually passed to the storage bag. And from the storage bag, it is now fed to the generator, where it's expected that up to 6.5 kilovolts hour amp of electricity will be produced and used to power the CG building. Next slide, please. Okay, so this is how it all started. We started initially the site was a thick forest, but we started out with clearing it, and then you can see how that was done, and essentially University of Benin was part of it, so we didn't do it on our own, so they were all carried along in the process. Next slide, please. And then while we were also doing that, we continued engagement with stakeholders. We've visited this school, the university staff school, and then the university demonstration secondary school, and made presentations to them at different engagements. Okay, we also took this campaign to the abattoir, where we met with the operators of the abattoir, the Edo State Abattoir Association, and then we made presentation to them and for them to have a buy-in of our intention. So essentially, at the early stage, it wasn't very easy getting them to accept our project, but after we did that, and then in fact, in one of the occasions, we had to distribute nose masks to them, you know, letting them know that we're also mindful of the current pandemic, and then, you know, it became the environment became friendlier for us to be able to speak with them. And, you know, it was at that point that we saw that they were really interested, and they were actually waiting for us to come and take these weights, and they assured us of the availability of this fecal matter from the cattle rumen whenever we are ready. Again, we did the same thing with the secondary school and the primary school severally, you know, through first of all getting the teachers into our meetings, and then having private sections with the teachers before we also moved on with the student, you know. So through the teachers, we were able to gain access to the students, and we did a lot of engagement with them. As of today, we are very happy that all of us are now working together. You know, even when sometimes they were not there at this construction site, but we took the processes to them, we recorded them, and we took them to them, and they had a lot of interviews with us at different points. Next slide, please. Okay, so as you can see, these are still part of the engagement, because we also know that we need to take these waste, this knowledge to other prospective farmers and farmers in different locations. So as you could see, in one of these engagement, we went to Osa Farm, you know, somewhere in Benin. Is about the largest farm. You know, we thought that we were able to get some of their get some of the animal waste for this project, but they told us that what they have more is more of plant waste. So in fact, it was at that meeting we also discussed potentials for using their waste, for other forms of proposals, which they are also keen to have some more further discussions with us on that. We also went to some other farms, smaller farms like poultry farm, somewhere in Benin, and we had a series of discussions, and then, across a range of farms. Okay, so please, next slide. Okay, so yeah, as you could see, these were also some other engagement that was even done outside Edo State. We had to travel to Delta State, the neighboring state to Edo State, to meet with Coastal Marine Areas Development Initiative in Warri. We also did that to Partnership Initiative for Niger Delta. Of course, in some of our meetings, I think in the last meeting or so, the engagement meeting webinar we had, and Florence, Agbedorn, and one of his staff member were also present. And then we also have other engagement with the Nigerian Environmental Society. Okay, so these are just to tell us how well we have gone discussing and having useful engagement with our partners. Next slide, please. Okay, so of all this we're doing, what's our goal? Actually, the whole process is we're looking to be able to produce enough gas. And to produce enough gas, we will need up to 30 cubic meter of digester size to be able to do that. Now, this project wasn't this big, but after we engage with our stakeholders and then be able to size the kind of demonstration we want to have, it was generally discussed and it was expanded to be able to cater for at least up to 6.5 kilovolts kilowatts of hour of electricity. And to achieve that, which means that our storage bag for biogas have to increase. And again, we have to be able to make sure that we have these waste available for use in the digester, which is why our stakeholder engagement was expanded to more farms and also to assess the availability of this feedstock. So, and if we have up to 30 cubic meter of gas, and we're able to have this up to 20 cubic meters storage of gas, it then means that we will be able to at least sustain power for up to 8 hours a day, at least to be able to cater for a proper working day, which means if I come to work in the morning, I should be able to stay with this light up to 4 p.m. in the evening, which is a great boost. And this really adds up to making the workflow in University of Benin, especially for recirculators and actuators, something to really look up to. Because, as earlier said, there could be outages and this actually disrupts work hours. So if we're able to achieve this, the university will be happy to even expand this. And this we're also looking to be able to sell to other people to show them what we've been able to achieve with our waste. And now looking to expand it, taking it through to our partners to be able to see more buy-ins, especially for those who are now interested in building businesses around it, which on the whole impacts on the general public and the user community at large. So if we do this, we're able to take away up to 7,500 kilograms of waste for each run from the deployment of this waste for biogas production. Okay, so if we do this for up to 4 times a year, which means that we'll be able to get off the street up to 35,000 kilograms of waste, which is massive and which is a big achievement for ACTUATE project, and something really good to beat our hands on our chest for having achieved this. Next slide, please. So I'll just show us the current state of the project. This is just showing us where we are now. If you look at towards the backside, you will see a water tanker that is now being installed to feed, to be able to provide reasonable water that is enough to be able to feed the digesters, because we do need a lot of water in this, and we have to make sure that our water is there anytime we need it. So this is actually a backup for us. It's, if we had opportunity to look around the site, which I'm not sure we're able to do that here, there are water wells around and boreholes around, but to be able to create a backup and to assure ourselves of the integrity of our project, we have to provide water for our plant. Next slide, please. All right, so we expect that the waste comes in here, and then some just around these two round tanks, we would macerate this waste and then feed them the waste into these what we call the first storage tank. Now, essentially, these tanks are to be covered such that the smells will not be a problem to the nearby habitats of this environment. So we'll cover them, making sure that everything is done. Essentially, it may interest us to know that we have carried out a detailed hazard studies on this project. We've been able to do a hazard, identify the project that may be the hazard. We've been able to identify the hazard that may be associated with this project, and we have also gone ahead to see how we can operate this plan, bearing in mind, and then making sure that all the hazards are now being addressed stage-wise. So we've been able to do all of that. So now the waste will come in and then mixed in the first tank, then transferred through a pump to the second tank, which we call the batching tank. And then from the batching tank, it is now transferred to the digester. If you go to the next slide, we'll see the next slide, please. Yeah, so these are the two digesters that receives the mixed and batched waste. So the hopper receives it and it goes into it where it's allowed to be digested. Essentially, there's also safety considerations for this. If gas is produced, we hope that the gas could be overpressured or under pressure. So if in the case of overpressure, there's a gas relief valve to also make sure that the pressure is not a risk to the operators and people around the site. So, and then the gas is safely transferred to the storage bag. If you go to the next slide, please. Next slide, please. So now, okay, this is just to show us the current state of the back of the digester. So this is where we collect the digestate. Okay, so in between these two digesters is going to be a pit, a slurry pit, where we will receive the digestate, you know, after the biogas has been produced, and then collected for further studies to be sure that the pathogen level is reduced to as low as possible before it is further used for planting. Next slide, please. All right, so this is the housing for the gas storage bag and the generator. So we hope that gas produced is transferred from the digester to the gas storage, which is yet to be installed. You know, so as soon as what we're looking to get that installed as soon as the water is the water tanks and the runoffs are properly installed. So we will get the gas storage installed just after we have also fed the digesters. And then the gas produced will be passed through some cleaning devices before it is passed to the generator and then test run. So this is basically where we are in terms of the construction. Okay, so I think I will have to put here that this project is a lot of people are looking forward to seeing this project work, especially, and they are also very thankful to the funders of this project for getting this kind of project and partnering with University of Benin to execute a project of this magnitude, which a lot of people are looking forward to benefiting. The students are at different times, they come in for explanations, and we take back this knowledge back to them at different times. So we are very keen and very happy about the project and the state and the way it's evolving. I think this will be my last slide before I, so just to let us know that the construction, we are at the concluding stage of the demonstrator, and then we are in the coming weeks, we are looking to do a project, a launch ceremony, and then after that, we also hope to commission the plant and then also do performance evaluation at the end of the project. Okay, so I don't think if
Thanks,
I'm having
Mike.
another. Okay,
I think
yeah,
that's
thank
fantastic.
you.
Much appreciated. So I think just make sure everyone understands. If you've got any question at all to any of the speakers, please, you don't have to wait to the end of the session. You can just write your question in the chat section. We'll pick it up and direct it to whichever speaker as we progress. Very quickly, I'd like us to actually invite Nina Ani, the CEO of Avenam Links, who is actually a project partner, to give us a sense as to the technical dimensions of the actual construction of the plant itself. She'll be very, very brief, but I think what she has to say is absolutely important, a piece of information for those on the call who are thinking about the opportunities around waste to energy, and Nina actually lives and breathes these systems. Nina, over to you. Thank you. So Nina, would you be sharing your screen, or should we? We can't seem to hear Nina at all. Hello, Nina, are you on the call? Hello.
I don't think she's on the call. I can't see her name on the list.
I think we can progress. There's probably something wrong, because I know our microphone is not muted, but we can't hear her at all. No, we can't hear you at all.
Yeah.
We can't hear you at all, Nina. She's actually on the call. Yeah, because she just sent a text on the chat section that.
Yeah, I see her now. I do apologize.
So, okay, you know what, Nina, let's do this here. Maybe we'll try and figure something out, because we are working with time. Could you hold on your presentation? I would like us, based on the earlier presentations from Kirk, from Roger, and from Mike, let's have a session of interaction through a Mentimeter questioning with the participants on the call. So I think we can move on to that quite quickly, and we'll try and come back to Nina later. So Nina, let's try and figure out what is happening, why we cannot hear you, please. Maybe you could leave the call and rejoin. But I think for now we can move on to the Mentimeter questions. Alan, yeah, let's do that. Fantastic. Beautiful. Now, is everyone on the call? If you look at the chat section, there is a series of links that has been posted. And it's just to cover a series of questions I'd like us to ask each other and to kind of respond to them to get a feeling and a sense of the room based on what you've heard so far, or maybe even based on a wider understanding of the waste to energy dimensions as far as Africa is concerned. And we'll capture the responses live on the call so everyone can see. Now, the first question is, in your view, why is, I mean, obviously you've heard that waste to energy is important, it's fantastic, it's beautiful, it's been done internationally. The question is, why is waste to energy not very mainstream in Africa, even though it seems feasible because it's happening internationally? Why is it not yet mainstream in Africa? Let's vote, please. What do you think, in your view or opinion? Is it because of the low knowledge of the technology involved? Is it because of an inherent dependence on fossil fuels? Or is it because of a lack of government policy or support frameworks to make it happen? Why, in your view, why do you think is the real issue? Why is it not mainstream yet? I'll be interested to know. And obviously, I agree that these three options are not exhaustive, which is the reason why the next question would give you an opportunity maybe to say a bit more about it in your view. So, but for now, as a sense of a selection, in your view, why do you think is a reason from the three options? Low knowledge of technology, dependence on fossil fuels, lack of government policy. Kek, could you just get ready? I'd like you to respond to this thing about low technology or knowledge of technology. Is obviously from people's conversations or responses, it seems low knowledge of technology seems to be a big factor. Now, Kek, could you just quickly talk about the whole thing around waste to energy? Does it require intensive supersonic technology to make it happen, Kek?
So the technology, I mean, is in principle, it's very, very simple. You put your waste into a sealed drum and let the microorganisms decompose the waste to produce gas.
That's simple.
It's very, very simple. I mean, obviously the engineering around that there is an engineering component to this and understanding how you join things together with pipes and so on. And there are some complexities around that. But in essence, anaerobic digestion has been used for hundreds of years, whether we called it anaerobic digestion or not.
Okay.
But yeah, I mean, I think the technology is well established, but whether or not it is available to our communities is another matter, of course, as well.
That's interesting. So obviously, the technology is actually available and has been available for a long time. But I think you're referring to the appropriation or the adoption or the adaptation of the technology for local conditions is what the fundamental issue is. So
well, I think that's certainly one of them. But I mean, looking at the three options that are on the table,
yes,
I would actually, not that we can do this, but I would say that all three are relevant. And as you said, there are probably some more that are not here that are also relevant.
Okay, you know what? Let's probably even move to those some more that are not here, because maybe folks in the room are thinking, well, there are other things making it not mainstream. So if you go to the next question, we can check that quickly. So next question now is actually giving you an option here to respond using a phrase, a sentence, a word. In your view now, okay, just to expand those options, what are the challenges of setting up waste to energy plants in Africa? What do you think? So forget about my options, the earlier options. In your view, what do you think are the other issues of consideration? Why is it not mainstream? Let's go, please. So this should be on the chat section. There should be a link for folks to respond to this second one. That's the second link, please. Okay, so people talk about education. So in some sense, maybe that's kind of tied to lack of knowledge of the technology in a sense. So, but there's also an issue around finance. So that means even in the case where there is the available knowledge, there's some support government frameworks or policy in place. But how do you find funding? Someone else has mentioned funding. Any other issues people are thinking about? Why is it not mainstream? So funding is obviously an issue because, yeah, I can assure you, Kek, I don't think that the plant in Nigeria just showed up from space and then people woke up in the morning and saw the plant. Some money went into that. Is that correct? So there is waste not being sorted. So even the characterization of waste in the first place is also an issue. Someone's talking about awareness. So the consciousness of these systems existing seems to be an issue. The value of waste. So do you attribute value to waste in the first place? Someone is talking about technology, the historic failure. I like that, because over many years, people have kind of thought about, well, waste to energy never works, and obviously built some kind of an historic backdrop that maybe is not fundamentally true, because maybe things haven't worked before. It doesn't mean that they cannot work. Maybe some things were wrong in the first place. Okay, thanks, guys. And that kind of gives a sense of other issues that wasn't considered: knowledge and awareness, funding, government policies, education, and all of that. Beautiful. Now we can move to the next question, please. Okay, so the next question is a bit of a bit tricky, but I would like to get Kirk, get Roger just waiting to respond to whichever answers we get here, because I have no idea what's going to come up. And the question is this. So if you click on the chat, the question is, so waste to energy plants. So waste to energy plants helps to manage waste. Okay, it helps to produce energy that can power environments, power facilities. It helps to produce fertilizer because of the digested left after the plant process. So, but the point is, which of these is most important to you? Which is most significant as far as you're concerned? So, Kek, be on the lookout, because I'd like you to respond to this. And Roger and Mike, and anybody who's got some views about what they are saying. I mean, it's not an exhaustive list, but please, if folks can keep voting, please, so we can have some more numbers on this. Then I'd like the experts to respond to why do you think this is happening here. Okay, so please keep voting. We've still got some little time to get through this. Thank you, guys. So is your focus on the waste management? Is there a focus on the energy generation? Is there a focus on supporting agriculture? It seems to be at par. Okay, what do you think? What are you seeing?
Well, I mean, it's pretty much equitable across the piece, really. I mean, I think people see the value of this across the three core elements of the waste, energy, food nexus. It is interesting that normally you would expect one to go shooting off. But here I think people have got generally an equitable appreciation of the importance of this across these three different sectors.
So I think someone like Doris in the chat just said that, in our view, because they're quite linked together, the choices are linked, so it's difficult to isolate one, which I agree with her, makes sense.
Yeah,
there's also another comment from Informa says waste segregation in Nigeria is very poor. So if you get it right, then we can diversify power. I absolutely agree with you, Informa. Anybody else making comments? So Mbagu Chukwe Buka says waste management is to reduce environmental pollution. That's absolutely correct. And so, Roger, what's your view on this sectioning of this dimension?
I think the waste management covers all three, the whole lot.
Okay.
The word management is the key. One is, for me, getting rid of it and improving health is important, but what do you do with it? Let's do something useful, produce energy, support agriculture. So waste management sits above the whole thing, and what you do with it is the management part of it.
That's beautiful. Absolutely fantastic. I think we can now go to the last question for this session before we invite our friends from Ghana. So Nina, just hold on. I will come to you at the end, because what I want you to do is paint a picture of an actual process of waste to energy plants working in Nigeria, which your company has helped to set up. That would be a wrap up for the whole day. So, but for now, let's take the last question before we move to the second Ghana partners to give their own showcase. So the question is this: how best can waste to energy plants be funded in your view? So is it should be government sources, private sources, international donors, or a combination of the three? How do you think, how best should, because I think the issue of funding came up during the challenges. Why is that mainstream? So let's kind of delve into that a bit further. In your view, how should this be funded? Should you focus on government, private sources, international donors, or a combination of the three? Andrew, so if you're on the call, I'd like you to kind of come in here once the people's options comes through. because you're a panelist and a speaker today. So I'd like you to give us a sense as to what you are seeing on this option. So I think that the preference here is a combination of the three. On the chat, we've got comments around waste segregation. So this is Alistair now. Oh, Alistair, good to see you. Thanks for coming through. Waste segregation isn't great in the UK either. It's a balance of risk. So do it as a process operator or rely on the competence of the waste producer. That's absolutely powerful. Alistair, if you're able to speak, can you comment on this, please, what you're seeing on the screen? So there's a preference for combination of three, but I think the point is, how easy it is to have this combination working seamlessly? What's your view? It's not as easy as it sounds.
So waste segregation in the UK anywhere is actually quite poor and usually not good enough for any of the processes. So waste to energy, whether particularly with something like AD, what we find is the waste producer, which may be families at home.
Okay.
Actually, they are not particularly good at separating the waste. They don't really know what they need to do because some of these waste separations are quite subtle. And even in the UK, pretty much all of our waste, although it's segregated at home, is subsequently sorted again.
Interesting. Okay.
So actually, having people segregate waste at home does not eliminate the need to do it yourself anyway. So this is why it's the balance of risk. Are you going to risk having your process, your AD process, clogged up by plastic bags because somebody thinks a particular bag is biodegradable and actually it's not? Or do you use your own expertise but recognize what is and is not biodegradable to do the sorting? Personally, my feelings are lean towards doing the separation yourself as the process operator.
That sounds good. So
it's something that needs to be thought about.
So I think Mbago Chukwuebuka makes a very strong point. I think he thinks well, it's private sources. The government has no business. I think he's very emphatic here. Government has no business managing waste. If it's it's profit driven and leads to more innovation to cut waste and maximize wealth. And I think I can see where she's coming from, because ultimately government can produce the enabling environment to increase innovations around making waste to wealth a functioning commercial proposition. But unless that happens, even private sources would also struggle. But I think is that balance between both. So thanks everyone. Please, if you've got any views, don't wait, just post them on the chat. I will pick them up as we progress. But it's a good time to invite our friends and partners from Ghana to give their own showcase. So on the list would be, so to invite them, I want to introduce Dr. Richard Bayitse, who is a senior executive at the Council for Scientific and Industrial Research in Ghana, and she would be supported in this presentation by Mrs. Patience Agbedorn, who is a social scientist, also at the Council for Scientific and Industrial Research in Ghana. But the point is, the Ghana project wouldn't have been successful without some important and powerful partners who have been phenomenal, I have to say. And they include folks from the Hartog Foundation, in specific reference to Samuel Dotse, Bennett Akufo from Green Advocacy, Jacob Nkunu from Sewerage Systems Ghana Limited, and also the lead of the project in Ghana, Dr. Francis Barton Ajani, who is also director of the Institute of Industrial Research in Ghana. And so on that note, let me welcome the Ghana team to give us a showcase of their progress on their own project so far, which I think is a different dimension to the waste to energy presentation. Over to you, Richard, and your team.
Yeah, thank you, Akan. You will be controlling my slide from there.
Yeah, so Alan would screenshot your slides, then you can just say next when you want to go on to the next one. Fantastic.
Okay. So as you already introduced. I'm doing this presentation with Patience Agbedorn. And Alan, please can you give me the next slide? Yeah, the Ghana project is slightly different from that of Nigeria project because of the size of the biodigester, and then the involvement of different project partners. If you look at Nigeria, the project partner is one, they are doing everything. So it's quite a bit simpler. But in Ghana, we have different project partners and we have to work as a team. So I will not go through the background of the project because previous presenters have elaborated enough on that. So I will not go into that. So I'll just give you what we have done in Ghana and what we are expected to do. We haven't finished, we are still ongoing. So that is what I'm going to give you. So the next slide. Alan, next slide, please. Yeah, okay. Yeah, as Akan said, the project partners in Ghana involve 5 key partners. We all have our unique activities and strengths that we put together. And the most important thing is our collaborative work will end up in producing a demonstrator biogas plant and a show lab. So Hathor Foundation is basically involved in giving publicity to the project and also engaging communities and stakeholders on the project. Green advocacy is supposed to establish the show lab and then also educate the students on waste segregation and then collection of waste and bringing them to the demonstrator for biodigestion. Sewerage Ghana Limited, they are more or less like an advisory body to the project because of their vast experience in running huge commercial sewerage processing plant which produces biogas in Ghana. So they have that expertise, so they came on board with that. CSIR is involved in design and then construction of the biogas plant. As we all know, CSIR has been building biogas plant since 1987. So we have that expertise of designing and building different type of biogas plant. Next. Yeah, these are the project activities. I don't need to elaborate on those once again. Next. Yeah, so I would like Pat to come in and give us the social science aspect of the project as we have undertaken so far. So Pat, take over from me.
All right, thank you so much, Dr. Bayitse. Okay. Yes, so I'm continuing from here, the social science part of the project. So first of all, we had created a platform and an inception meeting, which was between the project partners and stakeholders, people from the ministry that are in charge of waste management in the country, and shared the project with them, also learn from them, their contributions and advice they will give us on how to propagate the project. Next slide, please. Yes, then we also did community and stakeholder engagement. Again, the stakeholders and the partners and community leaders, key people who are key and leaders in the community were invited, and we also projected a project to them, had discussions with them. They also gave us their ideas. Even people even came up with suggestions like ensuring the project, because we'll deal with gas and issues like that. In case of any emergency, we'll have to ensure the project, which is also in progress. So we learned a lot of things from them, and also to help them own the project for sustainability reasons. Next slide. Then a community there, but this one opened up beyond the community leaders and stakeholder meetings. We invited people like parents and community members who live around the catchment area, and also projected the project activities to them. Also, we took contributions from them and how we can help the project be successful in the community. And they also gave us their ideas, their contributions, and we made them to own the project, understand what we are about to do in the community for their support. Next slide. Yes, there was also a media engagement so that the project can be propagated in the community and the whole of Greater Accra region. So this engagement was also done in the school. We invited the media, they granted interviews to understand what the project is so that they can also propagate it and announce the project for everybody to be aware of it. Next slide. So still continuing with the media, one of our technical men who is working on the biodigester and the headmaster of the school were invited to one of the TV stations in the country. They discussed the project deeply, how the project works, how it started, where we are going forward to, and then this one was aired on the TV station for people to be aware of the project. Next slide. Then we came to sensitization of students on the project. We had to sensitize the children because they would be taxed to bring the garbage from home to feed the plants. So we took one day, went to the school, sensitized them, and demonstrated how the whole process will be right from the beginning to the end for them to also understand so that they know what they are being involved in. Next slide. Yes, so this is a drone footage of the catchment area. We've flown a drone to capture the whole area where the school is situated and the community a little bit beyond the school. So this one was developed, and then we had to pick landmarks on the map to help the students be able to locate their homes on the map, because they will bring the feedstock from their homes. This one will help us to map the resource that will be used to feed the plants. Next slide, please. Yes, so the engaging the teachers to identify the landmarks. The teacher and one opinion leader who is an imam in the community, who says he has been in the community for, I think, over 30 years, very, very conversant with the community. So he helped us with the teachers to be able to identify the landmarks in the community, and this was superimposed on the map so that when we come back to the school to get the children to tell us where they live, then we will know where the resources are coming from. This man helped us, was very, very influential in that aspect of it. Next slide. Yes, so the next activity was the students to identify their homes. So this one, I went to the school with the map and the landmarks embossed on them. So we invited the students, showed them what the map is, the landmarks, where the school is, and very important things that they can use to locate their homes. So we call them, and the imam will help us with the students, tell them, mention specific spots in the area, and the students were able to point to us where their homes were. And interestingly enough, some of the students, even though they were not finding their homes in the catchment area, they were forcing to put themselves there because they wanted to be part of the project. So in this case, we had a lot of students who were able to show us their homes, which was about, I think, 80% accurate. Next slide. Yeah, this is the same process. This one, we started showing them on the laptop before we went to the board to show them. Next slide. Yes, so after the students showing us their homes, that one was also put on the map. So the one in the blue circles are the students, selected students and their homes. So this is how scattered they are. As they come to the school is in the green border. So the students were able to show us, they pointed their homes to us, which we put on the map before later we had to come back to the school. Next slide. Yes. So what we did after this one was we came back to the school with enumerators. The one enumerator will take 5 students, and the students will lead us to their homes. Then we check from the map whether what they showed us on the map is actually what's on the ground. And the accuracy, I think I can rate it as 80%, as I said. So they led us to their homes, showed us where their homes were at break time. Then they came back to school. Then we went on to interview their parents. And the interesting aspect is that because of the debates and the engagement, most of the parents were aware of what is going on. So when we go, they just open their doors for us, and we're able to grant them a lot of interviews, ask them questions, how they treat their waste, how they keep them, whether they are able to segregate them, a lot of questions on them, and they were able to answer most of the questions. But here, one thing I found out was that even though this biogas system has been in the system for some time, there were still people who don't actually know much about it. So I think the education and the awareness must be very much emphasized in this case. So we had done the survey, which is ongoing. We are about 70% done with that. Next slide. Yes. So here we see that most people, they tell us they are separating, but the only thing they separate is the sachet water and polythenes. They separate it because people buy them for recycling, for maybe other business matters. So people separate the sachet water from every other garbage that they have at home. We realize that they don't separate the degradable things like food, leftover, and they add all the other waste together. Then they separate only this one because of financial gains that they will get from it. So as we educate them, they said once, if we are able to bring bins for them to be part of the project, they'll be able to separate the organic waste for us as they are doing for this one. So maybe we think we can make some headway from there. Next slide. Yes, so far from the 70% of the work we have done, we estimated that about the 61 households, they generate about 550 kg of organic waste per day. This one we had to interview to be able to probe to get the figures to be able to estimate how much waste they can generate for us. And also about 9% of 9 kg of organic waste is also produced per household per week. And we think this one will also be a help to us. Then we also intend to involve fruit sellers and chop bar operators within the catchment area. After this section, we are able to get students that will select for feeding the digester. If you are not able to make the feedstock needed, we will also continue with the food sellers and the fruit sellers within the community. Thank you. I think Dr. Bayitse will continue from here.
Yeah, thank you so much, Pat. Yes, as you have seen now, we have reached the stage where we design the biodigester for construction. What we are seeing on the screen, we have gone through several processes of brainstorming, going through the rudiments of design, and this is what we have come out with. This is a 3D design. This design gives you the true perspective of what you see on the ground. If you look at this, I'm sure all of you will be able to understand and then read out what it means when you see it on the ground. So as you can see, this biodigester system, this is the first time we are building this type of biodigester in Ghana. I have not seen this type of digester built anywhere. What we have been doing previously is the dome type of biodigester. And then the next one we have developed from CSIR is the anaerobic baffle reactor, which is more superior to the fixed dome type of biodigester. We have chosen this type of digester, one, because the space that we have in the school is not enough for us to build a dome-shaped biodigester or anaerobic baffle reactor. If you see from the diagram, the new digester is placed on top of the septic tank. Two things here. We are going to use two streams of waste to feed the digester. We are using the fecal material from the septic tank and then the organic waste that will be brought from students' home. So these are the two streams of waste that we'll be using to feed the biodigester. What is unique about this system is that we are using solar energy to generate a gas which can be used for heating and lighting. So we are not going to use electricity. We are not going to use any energy source from electrical generated from the national grid. So our solar panel is going to give us enough energy to drive two DC motors that we'll be using to pump the feedstock from the septic tank and the organic waste tank into the digester. Next. This is just to show you what is on the ground. These are the technical people doing the actual construction on the ground. You can see them. What they are holding over there is the macerator. We have decided to make 2 units of the system manual. That is the maceration process and then the stirring process. We have made those 2 units manual because we wanted the students to be actively involved in running of the biodigester. So the students will be grinding the organic waste manually, and after grinding, the organic waste will go into the organic mixing tank, and over there, there is a pump that will push the organic waste from there into the digester. So that is the next slide, please. Yes, this is just to show you the lines that we have connected from the organic waste and the septic tank into the digester. Next. Yes, this is the connection of the gas pipeline from the digester to the gas holding unit. So these are all construction phases with pictures. Next. Yes, so this is what we have done on site as at now. You can see the biodigester system similar to what we have shown in the 3D design. So you can see we have the inlet tank, the outlet tank, the digester, the cylindrical container you have seen there is the macerator. So you can see the wheel. So that is the wheel the students will turn. And then we have cutting blades inside the cylinder, which will actually grind the organic waste. Then that will go into the mixing tank. Then the pump will lift it up there into the digester. You can see the solar panel on top of that. For security and safety, we have enclosed the facility because we don't want anybody to have access to that facility without authorization. So the structure on your extreme right, that gated section, that is where the gas bladder will be positioned before the gas will be channeled into the show lab. We enclose that place for safety and security. We don't want anybody to have access to the gas holder. Next, please. Yes, this is the show lab. As Roger talked about in his sketch, this is the actual show lab that has been constructed on site. So the gas lines have been passed into the show lab. We are going to demonstrate heating and then cooking in the lab using the gas that will generate from the biodigester. We are also going to show lighting. What we have, because the system is very small, so we will not be able to convert from the gas into electricity. So we are going to use the gas directly to light a lantern, which will show the students that the biogas can also be used directly to light for lighting. Not necessarily you have to convert it into electricity before you can light your bulbs. So this is what we have. The next, yes, as Mike said, a facility like this, you need to identify the hazards associated with it. Then you design a mitigative processes to address those hazards. So we have also gone through the process. We have actually developed the operation manual for the whole biodigesting system. And this is going to help the school and any other person who will be involved in operating the biodigester system, so that everything will be done according to scientific processes. Next. Yes, the activities that, no, next. Yes, so we have done all the initial testing of the biodigester on site. The first test we did is we have to find out if the system is watertight. So we did that. We filled the digester with water. We left it for some number of days. We have seen that the biodigester is now watertight. We didn't have any experience with leakages. The next thing we intend to do is to test for the air pressure. We need to pressurize the system and see if we generate gas, that gas will not leak through any part of our connections. So that is what we are going to do next. I'm sure next week we are going to conduct that. And for the safety of the environment, we decided that the effluent that will come from the biodigester, we have a return valve that will go back into the septic tank in case what comes out is not very good for disposal into the environment. We'll be running analysis on the waste to make sure that it conforms to the guidelines for discharging waste into the environment before we discharge that waste into the environment. We'll be using part of the digestate to green the environment of the school. The school is undertaking some greening of the school. So the digestate will be used to undertake that project in the school. So the biodigester will be used for that purpose. The gas will be sent to the show lab to demonstrate heating, cooking, and lighting for the students. And then the bringing of the organic waste to the plant, we are going to teach the students how to segregate waste, and we are also going to teach them basic environmental management practices. So we are not only going to produce gas and send it to the show lab, we are going to use that lab as an educational tool for students, not only at that school, but also within the community where the biodigester plant is situated. Next. Yeah, the social sciences part said we'll still continue to collect the data, and then we'll train teachers. The feedstock mapping, we are on it, we'll finish. Then we have MRV implementation, which I think Manoj and Co will talk about at a later stage. Next. Yeah, we also intend to do a comprehensive project documentary. So every activity that we are undertaking, we have been covering those activities. So we have pictures, we have short videos of all the activities that we have undertaken. And we are going to do a comprehensive documentary on the whole project, which we can share with the media so that they can showcase it on our national media. And then we intend to commission this project. In the next 3 months, this project should be commissioned, and then we invite the general public to come and see what we have done. Next. Thank you. So this is just a biogas, a stove, giving you a very nice blue flame from biogas plant. Thank you.
I think that's just fantastic. You know, I couldn't help but notice that both the Nigeria and the Ghana projects, even though they are both set in different environments, so while the Nigeria one is set within a university, where the University of Benin in Nigeria community provides the waste either from staff accommodation, restaurants, some student accommodation, whatever the case is, that feeds the plant. The one in Ghana is set up in a primary secondary school, where, but I guess my point is both projects in both countries kind of emphasizes the need for an important and relevant and strategic project stakeholder engagement process to get the community owners to feel like ownership of the project, because then you can assure, or at least almost assure, sustainability towards the maintenance and the continued existence of the project, or else it becomes one of those projects that has just been done in the top institution and that's about it. But also you talk about the intentional, by design, intentional incorporation of a manual element within the project, just to allow for young students to be involved in the steering. I think that's phenomenal. So that they learn practical skills. So I think for me it's quite fascinating to see. Now, before we hear the final session, which will be from Nina, I'd like us to have an engagement with everybody through a series of questions. Okay, then we can have the last presentation from Nina. Thank you so much, Richard and Patience. You guys have been fantastic. So good. If you look at the chat section, there are a series of new links on the chat. If you click on these links, they should open up new questions. So there's the one for the first link and the second link. So they just go through these quickly. So we actually watch the responses live on the call. So the first question is very straightforward. It says, I think I'm just going to get a sense of the room if people are enthusiastic about it. So would you recommend a waste to energy plan to be set up in your school or your institution? Would you? I would be interested to know if somebody would say no. So I mean, and that's okay, but let's find out why wouldn't you recommend it? So there is 7 yeses and no nos, which is good. I mean, which is also, it will also be good if somebody said no. I would like to find out why wouldn't you recommend it? That would be a good thing to find out. Okay. So it doesn't seem like no one would not recommend. So everyone will recommend, which is good. So next question, please. The next question is, so watch this, very important, this is very different. So don't forget that you've now learned after the showcases that both plans have been intentionally by design set up within schools. One is a university and one is a school. So in your view, which of these is most significant to you if you were to consider setting up a waste to energy plant in your institution? Would your focus or consideration be from a waste management perspective, an energy generation perspective, or an opportunity for practical employability skills for the students to learn practically? Which, in your view, would you consider as most important if you were to recommend that the waste to energy plant be set up in your school? So going back to the earlier question where you would recommend it, but what might be the driving force? What would be the interest point? Okay. So Mbagu's got a response here. She says that it would be better in an institution of higher learning like a university, but not advisable for secondary school due to the high inflammable nature of biogas. So, but I would argue, Mbagu, that the high inflammable nature of biogas still exists in the university setup. So I guess it boils down to the safety procedure and protocol within the setup. So I absolutely understand what you mean. There's probably a lot more risk in a secondary school setup as it is in the university. But ultimately, can any of the guys come on the call? Richard, what do you think? So can you respond to Mbago quickly? She's thinking that maybe it's not advisable to set this up in a secondary school. What is your view to that, Richard?
No, I think there is no problem with that because of the safety measures that we put in place. So it will not be of any difference. Okay. Because if you look at the setup, the bladder, the gas holder, is actually put in an enclosure where it is secured. So you will not have access to that place. Great. So it's just similar to how they keep LPG cylinders in schools, because when they cook, some of them use LPG to cook in some of the schools. And those cylinders, they contain gas. So I don't think there's any problem. And biogas systems, they don't have high pressure in their lines, which might even cause explosion or any other thing. We have other safety measures to release if there is any excess pressure within the system.
So it does boils down to the construction or the safety measure. And I think Alistair says biogas is not worse than LPG, which is quite normal. Everybody uses LPG and everyone knows that. So I think I see your point, but I think it's worth considering that there's been a risk assessment protocol incorporated into the design and construction to take care of that. So I think it feels to me like there seems to be a balance as well with respect to this question. So there's not one significantly higher than the other. So fundamentally, because they're quite well integrated, it's a showcase of a circular economy, but also the merits from a system of this nature, whether it's for waste management, energy generation, or providing an opportunity for practical skills for students to learn on those systems. I think it's beneficial within setups like that. Next question, please. We've got 2 more to go, and then I will call on Nina to wrap it up. So, would you be okay, it says, in using, I like this one. So this was an interesting question because this question came up in the survey that was carried out by the partners at the point of stakeholder engagement, where they went to local communities. And you do appreciate the fact that there is this still negative feeling vibe around using energy from fecal waste for cooking. Okay, so Alistair, I'd like you to come in this, Alistair, and then maybe Roger. So the question is, would you be okay in using energy generated from human feces for cooking? So obviously there is an overwhelming preference for yes, we would be okay with that. But some folks have said no, and I would like to know if there's anybody on the call who has said no. Could you unmute yourself and tell us why have you said no, or maybe respond to it in the chat. I would like us to find out why you said no, that you won't use energy generated from human feces for cooking. While the person does that, Alistair, could you respond to this feeling? What's your view?
So the use of biogas for cooking
Yes.
is really, for me, as a technocrat, it's a non-issue.
Okay.
So the biogas, we actually burn it, and the temperature of the flame, that lovely blue flame, is so high that absolutely no bugs, if you like, no pathogens could possibly survive that environment. Okay. And in fact, the environment in the anaerobic digester is in itself actually quite hostile to pathogens, so they die off. And the gas is, of course, completely separate from the liquid. The pathogens exist in the liquid phase, not the gaseous phase.
Oh, I see.
So we are several steps removed from the thing. And this is why, for me, as a technocrat, I have absolutely no concerns. It's quite interesting. There are situations around the world, particularly in arid climates, where it is quite normal to dry animal fecal matter and use the dried fecal matter as a fuel and to cook over that as a naked flame. Okay. Indeed, there are chefs in the United Kingdom who advocate the use of animal fecal matter for smoking of particular foods.
Okay.
It's completely safe, although I have to acknowledge food smoked over a poo fire is a little bit disturbing even to me.
So, Roger, you're a professor of microbiology. Is there any scenario where there will be transfer of pathogens, Roger?
No.
Which I suspect is the reason why some people don't feel so positive about it. What do you think?
I think Alistair said it. It's a separate process, you know, where the bacteria are, and the transfer of the gas to the cooking apparatus is a different process, and you won't get transfer pathogens that way. I'd be a bit more worried about smoking over poo, as Alistair says, but for producing biogas, from the bladder, if you went into that bladder and took a gas sample and tried to grow pathogens, you wouldn't get. I'm fairly sure. You might get things growing on the inside, but it all gets burnt off in the end.
Interesting. Okay. So last question. I guess this one is open to everybody because we've spoken about the need for awareness creation. Obviously, going back to the very first question where I asked, why is it not mainstream? It seems to be that a fundamental issue on the ground was the fact that people don't know about the technology. There's low knowledge about it. So how would you advocate the best process or systems or models or scenarios to increase the awareness of the benefits and advantages of waste to energy promotion in Africa? What do you view? So open just a phrase, a comment, just to get a sense of the room. How should this be better promoted, the awareness? I like that social media. It would be nice if any professor or lecturer or scientist academic working on these systems to write a blog or two on social media. I know, for example, Mike, Andrew, Roger, and friends on the court have been involved with writing blogs that is a bit more public facing around these systems to make it easy for folks to actually connect with them. Demonstration, I like that. So drama, short documentaries, education, TV broadcasts, educational curriculum, a range of very interesting ways to get people to connect with the fact that it is feasible, it is safe, obviously with the right parameters, and ultimately it provides a good justification to increase waste management, produce energy, provide digest for agricultural productivity, but also provide an environment for students to engage and increase their employability and practical skills. So I guess that kind of opens it up. So we've got some other comments in the group. So there is a community awareness, the media, school curriculum, public demonstration. I think also on the chat, we've got folks talking about the need for radio broadcast on the issues, TV stations, and these are different ways of increasing the awareness around it. Thank you very much. That's fantastic. Now, can I call on Nina to wrap it up? Because what I wanted to say is to tell us that it might sound like it's far-fetching, but she has been involved. Could you please show Nina's presentation so she can talk to it? Nina, are you on the call? Can we hear you now? She's still on the call, yes. So Alan, could you screenshot Nina's presentation? Thanks. It's been a very, very fascinating participation and discussion today on the call, and I can see there's a good degree of enthusiasm. And also, if you still have any questions, please feel free to ask it on the chat, and we'll direct it to any folks on the panel to respond to them. So Nina, are you on the call? Can we hear you now, please?
Can you see the slides right now? I have just shared them.
Yeah, we can see the slides.
Oh, okay.
We can't seem to hear Nina yet. Okay.
I suspect it's something on her end. I can. It looks like she can hear us, but we can't hear her. Akan, you're muted.
So Alan, I just sent you a link for you to to play this showcase on the call, just to show you what Nina has been involved with. It's actually a showcase by the TVC television network in Nigeria about one of her projects. So maybe you can showcase that, then we can wrap up the call. I think she's having problems because she can hear us. Obviously, she's on the call, but we can't hear her at all. And I wonder what it is. So for folks on the call, don't worry. We would share Nina's presentation to everyone on the call. But I think she wants us to just showcase. Alan, can you see that? Yeah.
I haven't got it yet, but have you put it in the chat?
In WhatsApp?
On WhatsApp?
Yeah.
Can you put it in the chat, please?
Okay.
Yeah, thanks.
Fantastic. There you go. Could you do that? Yeah, could you do that so people can just have it? It's just 2 minutes, but I think it's a showcase of a coverage of one of her projects on the ground. And I think I would ensure everyone on the call gets her presentation. But it's just to show you that this is feasible. So this is happening as we speak. And so for folks on the call to be encouraged, motivated about opportunities around waste to energy and the potential for its impact in Africa. Yeah, so.
The Nigeria Correctional Service says they will ensure all inmates are tested for COVID-19 before accepting them. The service stated this at the inauguration of liquefied gas-operated kitchen at the Maximum Security Custodial Center, Kirikiri, Lagos. Ivy Kanu reports.
That's mandatory before being allowed entry into the center. Before now, the inmates used firewood in preparing their food and had issues managing their waste. This unwholesome act is history with the inauguration of this liquefied gas-operated kitchen. The inmates can now cook their meals conveniently as demonstrated here. Her company handled the project.
The main reason for the project was they have a human waste management challenge. Trucks coming in to evacuate waste at all time, which is not sustainable cost-wise and traffic and all that. So we came in with this biogas as an on-site waste treatment solution. It's not just treating the waste, but it's also generating gas, renewable energy.
For the controller, this is aimed at improving the living condition of persons in detention centers. He said the use of gas in the kitchen minimizes security risk in the prisons.
It took us just about a year to put up this system. And what we wanted to achieve is to have an odorless environment, to have clean cooking environment for the inmates, and continuity in supply of cooking materials.
What are the measures put in place to stop the spread of the COVID-19 virus in the center?
We entered into an agreement with the state government for awaiting trial persons to come. They must have been tested and brought in with negative reports of COVID before we receive them. But for convicts, because they are fewer in number, we take them. Within a week or so, we will enter into arrangement with the health officials through the help of the Ministry of Justice to take them for test. They are tested and brought back.
The Nigerian Correctional Service says they intend to replicate the gas-operated kitchens at all prisons as can be accommodated in the statutory budget. Perhaps the most outstanding advantage of the project is its capacity to, amongst others, address health challenges associated with the use of firewood in the preparation of inmates' food, as well as serving the huge funds the federal government spends annually on the evacuation of sewage. Ivy Kano, TVC News, Lagos.
Thank you very much, Alan. That's fantastic. That's it. So that kind of gives an overview of an actual live project that's been deployed in a correctional facility in Nigeria, and this is now plans in place to replicate this across different other facilities. So it does work. It is feasible. There are different dimensions to the discussion, but ultimately it begins with an intent, it begins with drawing that little piece of drawing on a small piece of paper. Do you want to get it done? Getting the right partners in play, sourcing for funding wherever you can, and ultimately putting a project team in place and developing a system to actually implement a waste to energy project. And it is feasible, it is possible, and it is beneficial. It gives me absolute pleasure to actually invite Keck to give us a wrap up as we close the session. Now, for those interested in getting access to certificate of attendance and participation from the project, please, if you look at the chat section, there is an actual link. So just click the link. The link would ask you a few questions, including how you would want your names to be showcased on your certificate, and you would be sent that certificate. The link is on the chat. Please click it quickly to take just 2 minutes, fill your name and how you want your email address, and then it will respond to you with a certificate of participation. On that note, I call on Keck for a wrap up.
So thanks very much, Akan. And thank you to all of the presenters for the really insightful and interesting presentations. And I also like to thank the audience for engaging with us in this webinar. So much appreciated, everyone. I think what staggers me is how far the project has come in such a short time. I mean, we've basically started from nothing back in October of 2019. And we're approaching the completion of the 2 demonstrators in Ghana and Nigeria. And it is clear that, you know, this has gone beyond just a normal research type project. I mean, there are so many different people from different backgrounds involved in this, not to mention, you know, the multidisciplinary nature of the project, but also in terms of the different stakeholder communities as well, which is absolutely fantastic. And it strikes me that, you know, there are also issues of scale here as well. And we saw that, you know, and very nicely with the last example from the YouTube presentation, where we've got something really quite small and in the school in Accra. We've got something bigger on the University of Benin campus, and then we've got something that's even bigger in the prison in Lagos, which is fantastic. So it shows the versatility and the scalability of you know, the bioenergy demonstrators that we've been talking about today. Absolutely fantastic. Of course, the project isn't finished, and we will be talking about this again later on in the year, of course, as things mature. So stay with us. And of course, if anybody has any questions or queries or wants to get involved with us, we're open here. So please get in touch, whether it's with us at Lancaster or with, you know, our partners in Ghana and Nigeria. So on that note, I'd just like to thank everybody again. I'd like to thank you, Akan, for another well piloted session.
Thank you, boss.
Of course. So thank you, and we'll see you again all very soon. So thanks very much from me.
Thanks,
back to you, Akan.
Absolute pleasure. Thanks for joining, and I'm sure you had a good engagement today. And we're hoping to invite you for the actual project launch and the cutting of the waste to energy cake at some point. Obviously, maybe not near the bioreactor. I'm looking forward to further engagement. Have a lovely week, and God bless you all. Bye-bye.